Hello, everybody. My name is Mikhailo, and I'm a PhD researcher, not only, but whatever. Today I would like to present to you computational mental energy. So the main idea of this is that we can manage our mental energy and not the time. It doesn't matter how much time we have. It only matters how much energy we can spend. Okay, so let's go. First of all, I'd like to give you an introduction about our day. So when we wake up, then we go to some morning routine, skincare routine, and we have some breakfast, and then we commute into the work, and we are doing actual work. And after this, we have some lunch, and we commuting back from work to our place where we want to be. Then we have some exercises, physical activities, some time with family, and after we have a dinner, and finally, at the end of the day, we have some time for ourselves, for the rest. And this is where we actually spend some time doing some things, and we're going to sleep. This is our day. Nice. Well, okay, so we can divide daily activities. We can divide in four categories. First one, resting, when our brain is resting. Next one is eating, we can say that eating is the pauses between life. And next we have physical activities and work and studying, so some cognitive activity on our brain. Good. Now let's ask ChatGPT to generate our whole day, like by minutes, and we start and end. And we set the weight coefficients to define if it was extremely hard, like the super difficult, -10, or it was easy, +10, or not just easy, it was giving us a lot of energy. Okay, let's just start with wake up. So we just woke up at 8:40 and let it take 4 or 5 seconds. It took none of our energy, but actually it took some, but doesn't matter. Next, we had some, let's say, skincare routine, and we felt relaxed and so on. We felt like we felt that we got some more energy to do. Next, we cooked some breakfast, and it took some like 30 minutes, and we actually spent some energy, let's say -3. Let's move to the work task. So we've been working for 3 hours, and it was -10, extremely hard, tough, stressful, and so on. Good. And if we move back to the sleep, while I was sleeping, we are resting, we are restoring our energy. Okay, good. So we will get the idea. Let's move to the next point. Let's just multiply what we have, minutes per this weight. Okay, next thing, let's calculate for each activity actual difference of the start and end time and multiply by weight. As an example, so drink water, 840, we have 5 by module, and multiplying by 1, we have plus 5 points of unknown energy. Let's move to the work in task. So we've spent 3 hours, 180 minutes multiplied by -10, it will be minus 1800. So quite a lot. And if we sum up all our activities and multiply by this weight, we'll get minus like whatever, 5,000 or 400,900. And this is an example total raw energies that we've spent during the day. That's actually good, but let's make it a bit better. So imagine we can do this with our brain. So we can just measure activities that our brain gave using, as an example, this EEG with 4 electrodes. I'd like to show you this. So actually we can do it here. So you can see this. Okay. And I'll show it in a demo how it works a bit later. Also, small note, there is a paper reading about hybrid quantum classical framework for multi-constrained computational mental energy from multi-channel EEG streams. And I'll be talking about it later. Okay, next we have this called flow state when we have our challenge and skills, and or vice versa, actually doesn't matter. And we have this flow state, we actually forget about the time that we've spent during our task that we were trying to solve, and actually our ego too. But if our task is too simple, we are moving back to the boredom, and if our task is extremely challenging or hard, we are moving to anxiety. Okay, next, quantum computing. So quantum refrigerator or quantum computer. So actually here is a quantum, I don't know, maybe a computer, maybe refrigerator, depends. So we have those tubes with liquid, cooling liquid, which is going to almost 10 millikelvins or minus 273 by Celsius, depending on which region. If you ask kelvins in Europe, then we'll have Celsius. And then in the bottom, we have some qubit chip. Okay, about the quantum computing basics. So previously we had, or currently we have bits with 0 or 1, so it's defined by silicon with transistor. If the voltage bigger than 4.2 volts or whatever, it is 1. If less, then 1.2 or 0.8, then 0. Now we're moving to a block sphere. We have a superposition state with alpha and beta as probabilities from complex numbers, amplitude probabilities actually, and basis state of 0, basis state of 1 is vectors. And this is actually causing a superposition. And we have also, it's normalized since basis of 0 and basis of 1 in square, it's going to be a 1. And we're doing some measurements in this. Okay. And we have quantum architecture. We can actually run all of those things really on IBM. So we can actually select 3 qubits like this selection and run on our quantum scheme here, depending on how many qubits do we need. So small theory. Actually, right now, so we already have more than 127, but I'm sure in a couple of years it will be thousands. Let's see. Okay, let's go to the demo. Okay, quickly about the results. I measured eight activities like resting eyes, browsing, emailing, browsing some TikTok, reading some general literature, reading technical stuff, debugging, coding, and math problem solving on LeetCode as an example. And for each of those, I subjectively put some complexity of these tasks. On the left, we have computational mental energy rate in vernix per second. Vernix is my equivalent that I created a new notation for this. It's a microvolt square per second. And as you see is that for the coding, we have around 300 vernix per second. It's kind of a lot. And for browsing TikTok, around 100 vernix per second. So we're still, when watching some TikToks, we're wasting our energy. About the result, imagine if we compute or extrapolate by whole day. So as an example, if I was just browsing the whole day, I would have spent around 200,000 vernix per day, just was watching TikToks the whole day. For the coding part, I would spend 2.5 million vernix per day. And for debugging, around 2 million, and for math problem, around 1 million vernix per day. All of those things are subjectively done to me via measurements in EEG. Okay, let's move to the paper part. So currently, well, I would like to share with you in the end probably the paper to read how it works about the quantum scheme, which uses 4 layers. And let's go to the part where I will just put this one on me. Okay, so this is an EEG device. Use a center. I should have the box. And on phone, I'm will be visible. Like this. Oh, like this. Okay, amazing. So it's actually measuring voltage from my heads from 4 electrodes, and this is how it looks like. Okay, and now I will be streaming from to my PC to just figure out how it looks like this here. Let's go to the live, and okay, well, it's still calibrating a bit. So what we have here, we have here our activity from my brain, from electrodes TP9, AF6, F8, TP10. Next, we have the flow state, which is defined on a quantum computer by shots. And now we can have, like we have a lot of rest, and let me just measure it and close it and restart. Okay, so now we started calibrating. It might take a couple of minutes, maybe 5. I probably pause the video for this time. So what it's doing right now, it's taking some calibration chunk for 5 seconds to extrapolate the activity of my brain to define the baseline of this. And now we can set our baseline. So we just set a Smith session. So what's currently going on, and the result of each 5-second window, how it looks like, and how much energy I've spent during that time. As an example, here I've spent like 200 vernix during calibration. Artifacts won't be taken. Next, we have some activities with action analysis. So if we would like to measure activity, as an example, I would like to check how much I'll be like sharing or watching TikToks on my phone, and I'm just clicking like starting, and I'm scrolling TikToks and measuring how much it took. So it's actually an amazing research, to be honest. Well, surely I'm not will be spending this time in the video, but this is a general idea, and this is how we'll measure all those activities. And by the end of the day, let's just go to the presentation. So what we will have. So, all right, in a final, we will have the idea that we have activities and we can measure each activity and its complexity and define a quantum computer, the flow state, where we're in a flow state or not. An example in my understanding measures on myself. So for my subjective computational computation, I have 7.6 million vernix per day that I could spend. So it's actually good. As an example, for brushing my teeth, I would spend like 12,000 vernix. For coding for 3 hours, 2 million hours as an example, or similar to this. And we can do the same with finances like money and calories. And this is actually it. I'm grateful for you. So you can check the link paper and see you next time.